What's up everybody? I'm back in the shop and my next project is making a new shifter handle for my race truck. I have one in there right now that works just fine, but it was the result of an experiment that didn't really work out the way that I wanted to, and now it's time to make a new one. The dash in my truck I made out of carbon fiber, and I wanted some other components to match that. So I designed a new shifter. I have some material and parts in the door, and we're gonna check it out. So what do we have here? Carbon tube, these two aluminum pieces which will get pressed into the ends of the tube, nylon shift knob, and some adhesive. So I first designed this thing in CAD just to get an idea of what it was going to look like and figure out how the parts were going to fit. And then I had to figure out how to actually bond aluminum to carbon fiber. And actually I think the most common application you see for this is drive shafts. There's quite a few companies out there now that are making carbon fiber drive shafts, and basically the process is pressing in aluminum yokes to the ends of the tube, and then they have cavities in these pieces that they can then fill with adhesive, and it makes this really strong joint. Because these drive shafts now, they're holding 1,000, maybe 1,500 plus horsepower, which is absolutely nuts. And so I thought if I could design this correctly, it would make for a pretty strong shifter handle. And so what I actually did with these aluminum pieces was had two grooves cut in them so that it would give that cavity for the adhesive to sit in. And one thing that's really important with these adhesives is they have this recommended bond line thickness, which just specifies the thickness of the glue itself to achieve the maximum strength that it's advertised at. And so looking through a bunch of tech sheets of these adhesives, including this one, which is Loctite E120 HP, it seemed like they were everywhere from maybe 5 to 15 thousandths. And so on these aluminum pieces, these grooves are cut 15 thousandths smaller diameter than the press fit, which gives 7.5 thousandths to the inside diameter of the tube. So it's right in that range, and it should create a really strong joint. So basically I just have to cut this tube to whatever length that I want, and then I will start getting these pieces installed, and we'll see what we come up with. The tube has been cut and the ends squared off. So now the next critical step in this process is I need to prep the inside of the tube where the ends are going to be pressed in. And this is going to give a good mechanical bite to the adhesive. So I've got some 220 sandpaper, which will help me do that. And I could abrade the surface here where the adhesive is going to be in contact with these aluminum ends, but I want to go the least amount of work possible first, test, and then if I need to make a change, I can do that later on the next prototype. And the reason why I want to hold off on this for right now is because there's this phenomenon called galvanic corrosion, and this is a big deal in marine applications. So basically what this is when you have two dissimilar materials that are touching each other in the presence of an electrolyte, which would be water from the ocean or from the atmosphere. It can carry current and it'll accelerate how quickly these corrode, and then your joint can break down and possibly fail. So it's probably not something I need to worry about, and I'm probably overthinking it, but what this anodized does is it gives a barrier between these two pieces. And also, having a cavity for the epoxy to fill, the epoxy will give a barrier between the two pieces, so there shouldn't be any galvanic corrosion. But if I do sand these ends, which will be pressed in, and I have raw aluminum touching the inside of the tube, that's when this corrosion can happen. And so I just want to avoid that for right now, and again, go as the least amount of work possible, test, and then see if I need to make a change later. So I just need to get this sanded, and then we'll work on getting these pressed in. And I will be drilling some very small holes in the tube that will line up with the grooves in these pieces. That way I can inject the adhesive after and make sure I get a complete fill of the cavity. Otherwise, I feel like if I just put adhesive on this piece, put some in here, some of it will get squeezed out and I won't get complete coverage. So that's the plan. I have the tube sanded on the inside, got the holes drilled, and now I need to press these in, which that's the interesting part. I don't have a press. I can kind of start to wiggle these in here, so I think we'll just try to literally try to push this thing on the table and see if we can get these in. And then after that, inject the adhesive into these holes. Not bad. Nice. All right. Side one. Not too bad. That was a little bit easier than I thought. Maybe that's a good thing, maybe that's a bad thing. You can see it's a nice flush fit with the tube ends and the OD of the tube. And then you can see the two little holes there that I drilled. So I'll be using, it almost looks like the tip of a syringe to inject the adhesive down in there, and then that'll complete these joints. So then the shift knob, originally how I had this designed, I wanted to do a press fit, and then I changed my mind, which I've changed my mind about this like every 10 minutes it seems like, and other things just with the shifter handle in general. So I have this hole undersized by quite a bit, and what I think I'm going to end up doing is actually just cutting threads on this, which of course will ruin the anodize, and we just talked about the galvanic corrosion, but I would rather have a prototype where I can change the knob if I want to, because this may not be the final shape, and then I will cut threads in the knob, do a threaded insert so it's pretty robust, and then that'll be the finished handle. That's pretty cool. I really like how this turned out, and I learned a lot from this process, which is exactly why we prototype stuff. And I found with the adhesive, with only one hole per groove, there was no way to get the air out, so I ended up drilling another hole opposite to the ones I had drilled before. That way, as I injected the adhesive, it could push the air out and then completely fill each cavity. And then with the threads, I cut them by hand, so they don't line up perfectly, and the knob sits on there a little bit canted. I don't think anyone would be able to tell unless I told them, but obviously in a production part, they would be cut on a CNC machine, so they'd be absolutely perfect. So now the next steps for this, I'll get it in the truck and I'll put a clip up so you can see that, and then just test this thing. I really want to stress this lower joint and see if I can maybe break it apart, because I had the thought too, maybe I could put a roll pin in here to give it more of a mechanical connection, but that's kind of the process here. You just got to test it, see if you can make it fail and make it better. So thanks for watching, and I'll see you next time.